Okay, so we're at the second part of Unit 1, Part C. Okay, so we're comparing distributions now. So this is a very common kind of question. Make sure to use comparative words. One mean or median might be bigger than another, or just compare, use comparative words when you're saying, if the range in set A here in South Africa is larger than the range in the United Kingdom, clearly. And so make comparison, use comparative words. It's one of the biggest things here that I want you to do. You can see that the shape for South Africa is skewed to the right with a single peak at 4 people. And so probably an outlier there at 26 or so. There's a clear gap. So gap and outliers are two things that are unusual that it's good to talk about. So it's okay to talk about. There's a gap between 15 and 26. So that's something we haven't mentioned before, but that's an unusual feature that falls in the category of outliers. And it's, as far as the UK there, the second graph, it looks roughly symmetric. Can't tell if it's skewed or not. There doesn't seem to be any outliers. There does seem to be a single peak, so unimodal, at about 4 people. Outliers, again, the first graph, South Africa has an outlier or 2. And then no apparent outliers, clearly, in the United Kingdom. The center, the median, so you'd want to count the number of dots, find the one that's in the middle, and count until you find that one. And so it's about 6 people for South Africa and about 4. So the median, notice they use the word, tends to be larger for South Africa for the household size than it is for the UK. And again, right now we're just kind of going with, well, South Africa goes from about 3 to 26, and UK ranges from about 2 to 6. So a lot smaller variability in the UK. So again, talk about which one varies more or which one varies less. It doesn't matter which way you go as long as you use comparative words. That's the big thing with this. So once you get the hang of doing all that. It's not okay to just list the values. If you say the median of this one is 6 and the median of this one is 4, you won't get credit unless you say the median of South Africa is larger than the median of 6, is larger than the UK median of about 4. And use context as well. So when we say context, 4 people, 6 people. So we always like to talk in context there. What do those terms mean? And again, context, household sizes, distributions of household sizes. Okay, so stem plot, also called a box and leaf, box and whiskers plot is what I should say. Actually, no, this is not a box and whiskers. This is a stem plot. So it's called a stem plot, which consists of the leftmost digits of a leaf and then the final digit. Boy, we need to show what it is first. So this is what a stem plot is. You make your stems first. We'll come back to that page in a second. So you can see that all these 2-digit numbers, well, except for the 120, which is a 3-digit number. We'll get back to that one. But most, I guess 104, most of these are 2-digit numbers. The first digit is the 6, 7, 8, 9. And then for the 3-digit ones, we're putting 10, 11, and 12 for those guys. But the stem is like the tens digit, so to speak. But in the case of when it's more than tens, when it's hundreds, we're putting 2 digits there. The leaves are all the single, like the ones digits in this case. And so what that means is, and so this looks really weird at first. So do you see where it has the 6 and then the 8 is to the right of that? So that's the number 68. 6 on the left is the 10 digit, and then the 9 on the right is the ones digit, so 69. And so we always like put them in order. So that middle one with the leaves was kind of weird because it's not in order. I really like the one on the right better there because all those numbers are in order. You can see if you look at the sevens, the one that starts with 7, that's the number 70, 71, 71, 74, 76, 76, and 78. So every number on the right represents the ones digit of the stem on the left. So there's only one 120, there's one 104, there's no 110s or anything in that range. Always include a key, so you have to have a key. In this case, something like this, you just choose a random choice like 82 there. So 8 bar 2 is a student whose resting pulse rate is 82 beats per minute. And I like that because it included context, and it was just an example of where 8 is the tens digit and 2 is the ones digit there in that case. Let's go back to the how to do this. So you make your stems. Separate each data value to a stem, all but the final digit. So that's a good way of thinking about it. I really like that way actually because I usually think of the stem as one digit and the leaf as one digit. But the stem is actually every digit except for the last digit. So I like that better. Write the stems in a vertical column. So all the, in this case, the tens type of digits there. Do not skip any stems, even if there's no data value. So you have to keep those consistent on the left. Add leaves. So those are the ones digit in this case. Right, leaf to the row, order the leaves in order, and then add a key. Okay, so when the data values are bunched up, we can get a better picture. So why do we have a stem and leaf plot? Like, what's the purpose of that? And so, by the way, just so you know, this is representing, so 23.5 represents 23.5 inches is a player with a head circumference of that size, right? So like the number at the bottom there, 256, is 25.6 inch head circumference. The number 24.0 there, you can see the two numbers next to the number 24 there are two separate numbers. So that's 24.0 inches and 24.2 inches. Hopefully you're getting the hang of that. But one of the reasons we make a stem plot, you might go, well, why are we writing the numbers like this? Do you see this graph on the right here? So you can almost like turn this graph in your mind, rotate it 90 degrees to the left, or I guess it'd be counterclockwise, and then you see the shape of this, right? You can kind of see, is it roughly symmetric? Is it skewed right? Is it skewed left? And so forth. That's one of the big purposes of doing a stem plot. And again, make sure that you leave those gaps in there if there's a gap. And we might talk about there's a gap there. That would be an unusual feature of the graph. So let's compare the data for this one. So this is resting pulse rate and then after exercise pulse rate. It makes sense to me that most of the pulse rates after exercise look a little bit larger. So this is also weird if you haven't seen one where it's a back-to-back stem plot. So like the 6 on the bottom right there, that is the number 146 beats per minute. So the 0 next to the 12 there is actually the number 120 beats per minute. The 4 next to the 10 there is on the left is the number 104 beats per minute. The 0 on the right is 100 beats per minute, 104 and 104. So you have to kind of, even though it's on the left, you almost think of the ones on the left as the leaves that are on the right, but they just kind of write them backwards. And notice that everything's backwards. You even go from biggest to smallest there. So when they do that, that's how they roll. So what are the shapes of these ones? So you can see that the first one, the after exercise, seems to be skewed to the right, to be kind of tilted. So that one, the other one, you have to kind of reflect it and then rotate it counterclockwise. So I think that one also is skewed to the right. So they're both skewed towards the larger numbers is another way of thinking about it. Skewed to the right, and both of them are skewed to the right. And you can talk about where the peak is, right about 90 for the after exercise, and closer to 75-ish or in the 70s somewhere. Outliers. So outliers, it looks like there's an outlier at 146 for after exercise, and maybe 120 for the other one. The center, let's count this out. So if you look at the after exercise, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18, 19. There are 19 heartbeats that were taken, pulse rates that were taken after exercise. So 19 means the 10th term is in the middle, right? So if I count from smallest to biggest, 6, 7, 8, 8, 0, 2, 2, 4, 5, 8. So 8, that is the 10th term, is actually the 98 is the median pulse rate after exercise. Then you would count the ones before exercise. I'm sure it's the same number, so it's before and after. So let's count the 10th one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 6 is the ending there. So 76 is the median for the other one. So yeah, it's weird. You have to count backwards there. It's very difficult with a stem plot to do that. Variability. So right now we're just kind of saying the smallest to the biggest term there. So after exercise, pulse rates vary from 86 to 146, and before exercise, pulse rates vary from a small of 68 to a large of 120. And if that makes sense to you, you're understanding what a back-to-back stem plot is. It's just, the hard part is the shape there. You have to reflect the left-hand side and then rotate it counterclockwise. Okay, so here are some soccer stats here. The number of goals scored is represented there for many of the different matches. And Liverpool had 52 matches, and there were 49 matches for Manchester United. And so if you want to describe the shape of this guy, and actually just compare them, right? So what would you say for the shape? So shapes, both of these graphs are skewed to the right. Liverpool has a peak at about 2 goals, and Manchester United has a peak at about a single peak at 1. So median, you would then count the number of terms. Well, we know there's 52, so you'd count to the 26th and 27th term on this one. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think in that first one it says 10, 11, 12, 13, so that's 23. We want to get to 26 and 27. So 2 is the median for Liverpool. And if I count the one to the right, that's 49. So that'd be the 25th term, I believe, is in the middle. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, I believe. 12, 13, 14, 15, 16, 17, 18, 19, 20. It's 31. So it's definitely past 25. So 1 is the median for Manchester United. Outliers, it looks like 9 for sure is an outlier for Liverpool. Maybe 5 is for the other one. Somewhat doubtful, but it's possible. Maybe outliers at 7. We don't know how to find them exactly, so we're kind of guessing right now. Variability from 0 to 7 for Liverpool, and only from 0 to 5, which is a smaller variability for Manchester. So again, use comparative words when you're comparing different sizes. So this is what they said. So again, when they talk about the center or the medians there, it tends to be greater. 2 is greater than 1 for the medians there. And the number of goals by Liverpool varied more. So again, they're using comparative words there when they do that. Make a stem plot of these data. So describe the shape distribution. So are there any obvious outliers? So you want to do this one by hand. Calculator does not do a stem plot for you. So the biggest thing is when you do this is I want you to, hopefully this time it's working. Okay, so when you're making the bar here, so it looks like the smallest number I need, wow, so there's not a lot of numbers here. There's 4s and 5s. And so on the right, 4.8, is that the lowest? I'm going to try this. Let's see. Sometimes we have to break it up into smaller. I'm going to do this, 2 4s and 2 5s. So my first one is going to be 0 through 0, 1, 2, 3, 4, and then 5 through 9. So I don't, I can't do that. Sorry. So the thing is, I've actually got, because if you were paying attention to that rule, I didn't realize this. 3 digits are always harder than 2. 2 digits are pretty easy to make a stem plot for. So the last digit is the number on the right. So you're going to have to do something like, it looks like 48 is the smallest. So I'm going to say 48, 49, 50, 51, 52, 53, and so forth. You'd have to go all the way down to, well, might be enough actually. Okay, so 48, so there's a 7 there. I'm just going to put them not in order this first time. I'm going to go downward, so 5.02, 4.97, 4.92. Those are not in order right now. 5.03, 4.80, so that would be a 0 there. 4.88, 4.80, 4.90, 5.03, 4.93, 5.00, 4.99, 4.90, 4.92, 4.89. And I'm not going to do all of them here, but that's how to go about to make it stop plot, although I haven't labeled the key here. So you could say something like 49 bar 2 means equals 4.92 seconds, and then you put more of the context there. Stopping second, 5 seconds. I said how long it took them to stop their stopwatch, I guess. So this is the answer. It's a time of 5.24 seconds, and there's the shape, and you can describe the shape. So it does look like it's skewed to the right when you tilt it counterclockwise, 90 degrees. It's skewed towards larger values with a single peak at 4.9-ish there. There's no obvious outliers. I would say that again. And I like the wording. I like to read what they read. Sometimes I leave some things out. The distribution of times shown for the app for Mr. Tyson's 32 students. So very nice context there. We know what this is about, the distribution of times. Very good wording there. And then you follow it. So oftentimes you'll lose a point or lose some points for not showing context, not talking about context. So sometimes students get really good at like, hey, it's skewed to the right, there's a single peak, there's no outliers, the range is from here to here, but they forget to talk about the context. So one sentence in there about the context is sufficient. So you want to, that first sentence is key there to get full credit on these guys. That's your lesson for today.